Hey guys, welcome to the third video for this chapter and for the new year and decade. It's lesson 5-3, comparing and ordering integers. So if you remember, we did that back in last chapter with rational numbers, which included decimals, fractions, whole numbers, and percents. Now we're going to throw in a little wedge, and we're going to now throw in a periodic negative sign, okay? This should be one page. I'm going to make a chart that's going to be a little bit big, so I may end up having to use 2 pages, or 2 screens, but it should fit into your composition notebook on 1 page. So the table I'm going to make is about 1, 2, 3, 4, 5, 6, about 7 lines. So I'm gonna make it like this. Yeah. And what we're going to talk about is the numbers that you guys have been studying since you were little. So I'm going to create inside of that rectangle 1, 2, and 3 circles. Okay, and then actually I'm going to change that circle and make it a little bit bigger. There we go. Okay, so what we're going to do is go on the inside. Now we've talked about these different numbers before, but now we're putting it all at the same time. So in the innermost circle, we have what are called natural numbers. And we were talking about that in class. And natural numbers are the ones that you started counting when you were learning to count. So you would naturally start with 1 and then go 2, 3, 4, and so on and so forth. So natural numbers would be numbers like 1, 15, 2. All right, just to let you know, my cat Patches is scratching her face on my iPad and you might hear her purr, so be forewarned. Okay, now if you remember when we were talking about integers and their integers, and the definition said whole numbers and their opposites, and we talked about whole numbers were 0 and the positive counting numbers, and the opposites were negative counting numbers. So the next layer out is the whole numbers. And if you remember, there's only one number in whole numbers that's not part of the natural numbers. Just one number, but he's a pretty important number and he's pretty weird. And that is the number 0. Okay? All right, and then we go into that big title that we had the other day, and that is the integers. So notice that inside of whole numbers is natural numbers. So natural numbers are part of the whole numbers. Now that we're going to integers, whole numbers and natural numbers are part of integers. Okay, now what makes integers unique, so that's all I'm doing is numbers that are unique in these circles. So what makes integers unique is that now you can have negatives. So -1, -15, you could have -2, -327, and so on. Okay? But then there's one more layer, and he talks about not only all those integers that are whole numbers and their opposites, but now we want to include all those other rational numbers. So rational numbers include integers, whole numbers, natural numbers. Rational numbers now allow us to add another group, very important group of numbers. They would be things like a fraction, 2/5, a decimal with a sign, positive or negative, right? -1.5. We could have -3/4. We could have, a repeating decimal, which, by the way, we're going to talk about next week. So -3/4 with a repeating bar with a 4, okay? And then 0.2, 2/10. Okay, so all of these guys are rational numbers. So rational numbers include integers, include whole numbers, include natural numbers. So that means we're game for anything. So here's what we're going to be doing is when we are comparing, we're going to be using, again, the inequality symbols, okay? Or sometimes we may have something that's going to be equal. So we're going to talk about, we're going to compare. So compare is only with two numbers. So we're going to use an inequality sign. And I'm going to write underneath, that can be greater than. It could be less than. Or an equal sign. Okay, and then that would be equal to. So when I'm comparing two things, that's what I'm going to use, okay? Now if I want to put things in order, that means I have 3 or more items. That's when it's kind of helpful to use a number line. So we're going to use a number line. To help with ordering integers. And it could be integers or any kind of number, okay? Now, the guy that we also talked about yesterday, in yesterday's notes, was absolute value. So one thing that we were doing when we were trying to do operations, we had to take the absolute value of the numbers, individual numbers, and then we could do math with them. There was that one problem where there was math happening in the absolute value. We had to do that first before we could do the absolute value. So you must do the absolute value of numbers inside of absolute value symbols to determine their placement. In other words, I cannot figure out where to put the absolute value of -7 until I take the absolute value of -7, which is 7, and then I'm going to place it wherever 7 is. Now, it's still going to be listed as the absolute value of -7. Now, keep in mind, when I'm saying you have to take the absolute value, that's once you have one number only inside the absolute value, okay? Now, at this point, I'm going to go to the second screen. You should be maybe a little bit more than a third down the page, okay? So, again, I took about 7 lines for my guy. I made him long, almost as long as the page is. Don't make him too big, all right? And then we're going to continue in here. Now we're going to do some problems. So first type of problems you're going to encounter would be these. Fill the circle with greater than, less than, or equal to make a true sentence. Okay? So some of these are going to be super simple. So these first ones we're going to talk about are comparing. And how I know that is because there's a number, a circle, a number. So I'm looking at 2 things. Okay? So the first one is we've got 12 and we want to compare it to -4. Okay, let me just give you a real big hint right now. Positive is always greater than a negative. Think about on a number line, who's farthest to the right. Whichever value is farthest to the right, that's the number on the number line that would be considered the greatest. So in this one, since positive is always greater than a negative, 12 has to be greater than 4. So anytime you're comparing a positive to a negative, you don't even need to really think about it. The positive is always going to have the open part of the inequality. So 12, in this case, is greater than negative 4. Next problem, we've got negative 17, and we want to compare it to 20. So again, we've got the same exact situation. The only thing is different is the order. So negative is always going to be less than a positive. So negative 17 is less than 20. Perfect, right? Easy. 3. Now, here's where you got to go back to basic math. Think of your number line. Whichever is farthest to the right is going to be the larger number. So he's going to be farther to the right on a number line, so he's going to be the larger one. Okay? And then this is the one that gets tricky when you have two negatives. And the reason why this one is tricky is because you haven't done a lot with negatives before. So here's what I recommend that you do. Draw a little number line. So let's put a couple numbers in there. So we've got, let's place negative 7. Let's put him here. Negative 8, we've got negative 9, and we've got negative 6. So remember, we've got that number line in the classroom. The numbers are going, fanning out. You know how you have positive numbers 1, 2, 3? On the left side, with the after the 0, you have negative 1, negative 2, negative 3. So the numbers that are the biggest when they're negative are actually the smallest looking numbers. So again, I'm looking for who is farthest to the right. So if you look here, you've got this guy and you've got this guy, but he is farthest to the right. So what that tells you is that negative 7 is greater than negative 8. So again, think about it this way. When both numbers are negative, the smaller number is actually the bigger one because it's closest to 0. So I'm going to write that. Closest to 0 is bigger. Okay? All right, let's deal with the second thing we talked about. Directions ask us to order. So order the set of numbers from least to greatest. Okay, so remember the thing we have to watch out for is the order they tell us. On our test in Chapter 2, we had greatest to least, and most people had zero issue with that. So far in the tests I've been looking at, only one person wrote them the wrong direction. They went least to greatest, though the direction said greatest to least. So this is where we are going to order. So these are the order examples. So this means we're going to have more than two numbers. So sometimes what you're going to have is braces and then numbers. So anytime we have more than one number, they become a set. And when we use set notation, which means we use braces. So remember what we talked about. Number line. So here's 0. Let's put them in and we can think about them. So negative 9, let's see, we have a negative 9 and we have a negative 3. So that's how I'm going to kind of break down my vision, is with the negatives. Okay, so when I have my negatives, I'm going to have a negative 9 out, and closer to the 0 is going to be the negative 3. Then I'm going to look at my positives. And I have 0 and 6. Well, I got 0 already in, so that means we're going to put 6 over here. And then once I do that, I've got my answer. So here's my solution. The solution is negative 9, negative 3, 0, 6. So a number line is super helpful when we're trying to order values that are different types of numbers. Okay? All right, let's do, why did I number that one? You guys got to tell me this. Okay, let's go back. He's number 5. And let's do number 6. So number 6, we've got the absolute value of 4. Nope, I'm sorry, I lied. The absolute value of negative 4. There we go. We've got 3. We've got negative 11. And we've got negative 25. So before I can come up with my number line, remember what we talked about? You have to deal with this guy. So the absolute value of negative 4 is 4. So when I'm placing it on the number line, I'm going to place it in the spot of 4, but I'm going to label it as absolute value of negative 4. Okay? So let's draw a number line. Let's put our 0 in. And again, he's reference. He's not going to get graphed. He's not going to be part of our answer. In the last problem, he was one of our numbers. So I'm going to put a little note here. Reference only. It helps me separate where my positives are versus my negatives. Okay, so let's go ahead and get our negatives. So we already know the absolute value of negative 4 is 4, so he's not a negative, so we've got these two. All right, let's see, the smallest one is going to be the negative 25. And then we've got the negative 11. It's going to be closer to 0. Okay, now my two positives are going to be the 3 and the 4. So 3 is going to come first, and then I'm going to have the absolute value of negative 4. Okay, now notice that I did not give a fancy color to the 0. That's because he's not part of my set of numbers, so he's not going to be part of my solution. So my answers are, in order from least to greatest, negative 25, negative 11, 3, and the absolute value of negative 4. And there you go. Have fun with this, guys, and we'll see you tomorrow. Bye now.